All right, everyone, welcome back. This is Karthik from iTeLearn. So, session 2 in a little bit more depth in data sciences, handing it over to Prema. Prema, all yours, please.
Yeah, thank you, Karthik. Yesterday, I think in the session we'd seen about data cleansing packages available in R. Today, what we endeavor to do is to look into seeing how we download R, which is the very first step. Also downloading RStudio and getting introduced to inputting basic numbers, arithmetic numbers in R, and what is R capable of doing actually when it comes to performing various arithmetic operations. We'll have a look at that. We'll also look into what are the different characteristics of R, after which we will look into the different files that R can support by default without a help of packages. And we'll see what are the different ways of importing data into R. And we will then just touch upon little logical operations in R. Then the next session we will do hands-on session of what we learn in the class today. So the place to go and download R is you should log on to cran.r project. When you log on to this website, it'll give you options of what your operating system is. If it's a Windows, you click on Windows. If it's a Unix, you click on Unix. And if it's a Mac, you click on Mac. Once you click on that options, then it just gives you a click. You just have to click that button, and then it'll give you a zip file where you extract it, and it's ready for you. But R is very limited in its operation. Like when I open R on my laptop, okay, this is how R looks for me. I can only do things like assigning a value to R, right? Performing basic arithmetic operations, okay? But I cannot import data and work on data, neither can I graphically represent data, neither can I install packages. So then what comes into help for us is RStudio, because here I can import data from a data set, okay, using the import dataset command. I can install packages using the package commands, and I can graphically view my plottings out here. So to install RStudio, we will need to have R installed on our systems, which is like a backbone to get started with installing RStudio. If we didn't have R on our systems, we would struggle to install RStudio because it will just not even accept doing it for us. So preliminary is to install R, after which we just go into Google and type in RStudio. RStudio. And once we do that, it'll say download RStudio here. We just click on that. And it will give us a free download option, which is what we click. And then we've got to select the kind of system that we have. And when we click on any of the links, it will start doing an extraction. And once it gives you a zip file, you just have to extract it, and it will be installed on the laptop or the desktop, whichever. So once you have R and RStudio installed, I'm going to look into setting working directories and getting working directories, very limited commands, tomorrow when we do hands-on. Today, what I endeavor to do is do some basic, start off with characteristics of R. What is it that R permits us to do, and what is it that we cannot do? What are the limitations of R? Okay, as we know, R is a very specialized tool for arithmetic operations and statistical analysis. So if you see, I've assigned a value to an object X, which is 11, and I've set R. I've asked R to print what the value X is. It tells me X is 11. So what I type in here will be stored in my workspace. As you can see here, X is equal to 11 and Y is equal to 7. So then what I've done is I said Y is equal to 7 and I said print Y and it's given me the value. So as and when, you know, we just make assign values to an object, it takes an effect here and it shows you in your workspace what are the different commands you've entered and what is it there for you. So we can input values. Now, what I've done is I said Y is equal to 9 and I said print the value of 9. Initially, I said Y is equal to 7, right? Here I said Y is equal to 9 and I said print the value of Y. And it printed it to be 9 and not 7. So it means that R overrides values. If I assign the same object name to a value, it will override. So the memory, if I did not save the object name in cognizance with a particular value, it will override it. And that's what it's done here. From 7, which was what it was, it changed to 9 and it remained as it is. So one of the characteristics of R is R overrides values. The next characteristic is it is case sensitive. When I say case sensitive, if I went to RStudio and I said X is equal to 5 and I say to print X, give me an error. It says could not find function. Oh, sorry. Okay. It will say cannot recognize this value. Object X not found. If I say X, it will sorry, 1 second. Okay. So when I say print capital X, it says object X not found. When I say print small x, it prints the value of X is equal to 5. Now, it shows that R is case sensitive, which is the next characteristics of R. Okay. And the ls command is to show what is listed in your workspace. So it just shows me that Y is the object in my workspace. And when I say remove, RM means remove Y, and it will remove Y from here and clear the workspace. Okay. Now, the third characteristic of R is that when I assign a value to an object, the object name should always start with a character succeeded by a numeric. When I say that, the object name here is x.y is equal to 12. The object name is x.1. When I say print x.1, it tells me it is 12. When I say 1.x, which is the object name, is equal to 2, it will say unexpected symbol in 1.x. Because in the object name, R cannot recognize a numeric succeeded by a special character and then a alphabet. It should always start with a alphabet. The object name should always start with the alphabet and not a numeric. That is the third characteristic. The fourth is when I assign character values to objects in R, I always assign them in double inverted commas. Okay. When I assign numeric values in the same way, R will treat them as character values and not numeric values when performing arithmetic operations on them. These are the 4 main characteristics that we need to always remember. And we will see that, see each of these tomorrow in the session. In the practical session, I have a handout and we'll run through each of the command, but today we'll just do the theory bit. After the characteristics, I want to touch base on the basic arithmetic operations that R can perform, which is of so much of a different magnitude. But let's run through the very similar small operations like multiplication. It's given 12 into 12. And I said add x plus 1, x plus y, and it says that's 3, x minus y, x into y. I've given x is equal to 1 and y is equal to 2. And I've performed addition, subtraction, multiplication, square root of 4, log of 2, exponent value of 3, absolute value of 3, and so on and so forth. There's so many sine, cos, tan. These are different arithmetic operations that R can actually perform. And we've just seen a few basic, and we will see them in the practice as well tomorrow. After that, I want to touch upon R objects. Yesterday, when we were doing data cleansing, 99% of the time when we work on spreadsheets, we will be working on something called a data frame. 100% of the time. But a data frame, we must remember, is also derived from something called a vector, which is one of the R objects. So let's just look into each of these objects, what they are, and have a read through and see an example of each of them. Each of these objects in R do have 6 data types in them. So we can have a logical data type. We could have a logical vector, a numeric vector, integer vector, a complex vector, a character vector, and a raw vector. So these are the different data types that can come with any of the data objects that we have. Okay, and we will look into each of these types of data objects now. What is a vector? Until now, I've assigned a single value to an object in R. When I want to assign multiple values to an object in R, I do that using a concatenate function. If I want to say x is equal to 2, 4, 6, I assign that using the concatenate symbol, and that's called a vector. Vector is nothing but when you want to create vector with more than one element, we use the concatenate function, which is to combine the elements into a vector. Okay, and I'll show you how to create a vector in R. It's like, let's say y is equal to concatenate of 2, 5, 7, 6, whatever. We'll run that. That's a vector. A vector is created using this concatenate symbol. Okay. Now, what is a list? The next data object in R. A list is also an object in R derived from a vector. Okay, and it can have functions inside the vector. So I've created a vector with different numbers, and in a list you can also have functions like the sine function, tan function, cos function, or anything else, which was a complex data type that we'd seen in the previous. I could have complex numbers. Okay. What's a matrix? A matrix is a two-dimensional rectangular data set, and it is also derived from a vector. And it is created using a vector input to the matrix function. Again, I've used the matrix and to the, I've used the vector input to the matrix function, and I've given a concatenate, and I've said, so it's only two-dimensional. It is not multi-dimensional. Okay. Array is multi-dimensional. It is not confined to two dimensions like a matrix. What is a factor? Factor is also derived from a vector, but the values in the factor are always character values, not numeric values. And a data frame is also derived from a vector, But a data frame, you could have different values in each of the different columns, but each of the columns should be of equal length to perform arithmetic operations in them. So if I have the gender column to be 5 in number, then the age column should also have an equal characteristics of 5 in number, so that I can perform different descriptive statistics on the data that I have to hand. So one column could be logical, one column could be character, one column could be numeric, and stuff like that. And it is a list of vectors of equal length. As I said, it should be of equal length because we need to perform a lot of calculations on them. So if you see, I've just created a vector here, a data frame with gender as one column, height as one column, weight as one column, age as one column. And each of them have 3 rows assigned to them, and so that we can perform any arithmetic operations in them. Okay. After seeing the different, and this is how you create a vector, as you can see here. After the data types, I just want to go into using the sequencing command, have you go on telling R to repeat a number 10 times or 5 times, a sequence from 2 to 5 without actually giving all the outputs and stuff like that. And now I want to touch upon converting. I want to touch upon the nrow and the byrow command. So what I've done here is I've created a matrix of value between 1 to 9, and I said do it by nrow. Nrow means it comes row wise. So if you can see here, it is not, it is doing, sorry, it is doing the column wise. 1, 2, 3, 4, 5, 6. You see here, it's done it row wise. 1, 2, 3, because I set the byrow to be true here, and I set the byrow to be false here. So I wanted three rows, and I wanted the way this values have to come across in my data set should be row wise here, and it should be column wise here. That is all I've done here. And so you have to set the nrow byrow to be true here if you want it by row, and if you're going to set byrow to be false if you want it the column wise. Okay. The next is I've just created some values here, and I want to convert from numeric to factors, which is what we've seen in the previous class about data conversion. I said from numeric to character, character to numeric, and stuff like that. Now, an algorithm like Naive-Bayes will want my data, which is presented in this format, is numeric, but it wants them in factors like this format, because it can take in data only like that. So that is when this command of conversion from numeric to factor comes into place. I've created 0, 1, 2, 0, 1, 2. That's my data. And I've asked her, what is the class of X? It says it's numeric. So I want to convert this object X to a factor. So I said X is equal to as factor, convert X to as factor. And I said, what is the class of X now? It says it's factor. I said, give me the summary of X. It says 0 has occurred 4 times, 1 has occurred 4 times, 2 has occurred 4 times. So what I've done here is the numeric data, which is 0, 1, 2, 0, 1, 2, I presented the same numeric output here as 0, 1, 2 in discretized format. I've binned them, the frequency of occurrences of a particular number. So that is conversions from a numeric to a factor. And so on and so forth, we can convert from a factor to numeric also likewise. And here what I've done is, And we're going to see these in practice tomorrow. We're just doing the theory bit today. Now, I've also converted, I've taken age of the first 5 rows of my data set. From the age column, I've extracted first 5 rows. And I've got the age to be, I said first to 5, the sequence of first to 5 is giving me the age to be 22, 25, 30, 35, 40. I want to know if the age is greater than 35 and how to turn true or false indicators into 0 and 1 in R using the as numeric command. So I've said, I've used the as numeric and I've said age is greater than 35 and it said it is not greater than 35, it's false. It is not greater. It is not greater. It is not greater than 35. It's not greater. And it is greater, so it's given 1 here. So likewise, we can use the as numeric, as logical, as factor commands and convert from numeric to factor, factor to numeric, and vice versa. Now let's look into relational operators in R. In R, double equal to sign, or we could use is an equal to sign, and inequality sign is written like this. True is equal to true is true, true is equal to false is false, hello is equal to goodbye is false, and 3 is equal to 2 is false, hello is not is equal to goodbye is true. Let's look the relational operator lesser than and greater than. 3 is less than 5 is true, 3 is greater than 5 is false. Hello is greater than goodbye is true because R, like numbers, it takes in the alphabet in alphabetical order, the first alphabet. H is greater than G. It doesn't take the length of the alphabet, but the first alphabet. H is greater, so it is true. And true is less than false is false because true always coexistents to 1 and false coexistents to 0 in R. That is by default. And I've just done a few examples of relational operators. You can have a look through them when I send this file over. I want to cover some logical operators like the AND and the OR operator. AND operator is true if any one is true and it's false otherwise. It's true if both sides are true and it is false otherwise. Unlike, and I've given an example here. For OR operator, it is true if at least one is true, which is just the opposite of the AND operator, and false if it's only false if both are false, which is just the opposite of the AND operator. Now, I want to touch upon importing data into R, and I've also done a few examples here which can be viewed. Importing data into R, and it can be done 2 ways. By default, there are 2 files in R. It's a comma-separated file or the tab-delimited file, and this is a very important question because it starts off like this, the interview. They will ask you what are the 2 ways of importing data into R, and what are the default ways, what are the default files that R actually has? And the answer that would be expected is a comma-separated or a tab-delimited file. There are other ways of importing data into R. I can import a URL into R, an Excel sheet into R, raw data into R, for which I need to install different packages, and I can do it. But for comma-separated or a tab-delimited, it is by default I could do that. Now, I just tell R, give me help, give me the documentation for a CSV file, which is a comma-separated file. And this is how I ask R for help. Give me the documentation relevant to that, because I want to import a CSV file into R, and it will give you all the relevant documentation with help if we scroll below. Okay, and the first way of importing a data into R, there are 2 ways of importing each of these data files into R, and it is a very important interview question. I could import using the read.csv command or read.table command. So this is the way I do it. I've said choose the file. So when I give this command, what it does is it gives me a pop-up window, says, where is your file stored? Is it on your desktop? Is it in your, a C drive or a D drive and stuff like that? And when I use the read.csv command, I don't say how the file is separated, but when I use the read.table command, because I've not mentioned the CSV file, it says I separated by the comma separated file. Now for the tab delimited files, I use the read.delim command like the read.csv command. If I use the read.table command, I say it is separated by a tab delimited file. The two ways of importing data, and for each of the importing data into R, and there are two different files that you can import by default into R. Okay. Now, what is the importance of this $sign in R? Let's just understand that. If I just give a command saying, give me the mean from this data set for the column age, I'm using the data set name and I'm using the $sign because I'm extracting from this data set one particular column, right? When I do that, it will give me the output. But when I say directly give me the mean of this age column, it will not give me because I have not attached my data set and it is not sitting in my R memory. So because of that, I have to go on mentioning the name of the data set and the column that I require. Okay. If I actually go ahead and attach my data set like I did here, I can directly go and ask R, give me the mean for this particular column. So I don't have to mention the data set name every time. I don't have to use the $sign to extract. Because using the attach command, I have stored the data set into R's memory. And you can detach the data set when you don't want to work with it. And you have multiple data sets to work, so then you can detach particular and keep working, go on with your work. How to load libraries in R? We just have to click on the package and we've got to specify the name of the package that we need to install and it will do the installation for us. We could customize R going to the tools and the options command, and the default workspaces in R can be customized. Like I could take my visualization to the top left-hand side, my commands where I want to write my command to the right-hand side, my workspace can be, and I can color code, highlight, do the font using the appearance this thing, and I could change the layout of our studio interface. And there are many different options that I can do in this simple this thing by going into tools and the options in RStudio. When I want to visually view my data, there are different visualization techniques that we could use: a bar chart, pie, histogram, and each of them have their own different significance in the way we use each of them. A bar chart or a pie chart will display the frequency for each of the category. So if I say Hyderabad city and Bangalore city, the proportion of Hyderabad is 50% and Bangalore is 50. The number of people from Hyderabad is 50 and Bangalore is 50. It will give me a frequency for each category to be 50%. That is the plotting. That is what a bar chart or a pie chart does for me. Likewise, something like a histogram will be used for understanding the data. If it is showing a normally distribution or a skewness or a kurtosis, how is the data actually trending when I have a look at it? Because when I draw a histogram, it will project that to me. If I use a box plot, it will display to me the outlier in my data, the data value that is not projecting the average of my data, which may likely affect my statistical explanation of my data, is what I get from a box plot. A scatter plot will tell me the relationship between one variable and the other variable. So each of the different plotting graphs have their own significance for why we plot them, why we actually visualize our data using these kind of plots, because they each bring out a different characteristic. Now, when I want to plot a bar plot, I just ask R again, help with bar plot, and it will give me all the help on the documentation pertaining to the box plot. And I've just taken the gender column and I plotted a table of that. And it says the count of female is 14, the count of male is 15. And I've seen the percentage is 48 and 51. Okay. Now I want to plot the graph. So I say, draw a bar plot, and it'll say 48% and 50%. You can also label and give a title to your box plot, bar plot. You could also label your x-axis and your y-axis, as we've seen here. And you can also name your each of the frequencies as female and male. Same with a pie chart. I just say, give me the pie chart, pie for the count, and it says the contribution of male and female. It's just about the way the graph is comes. A pie chart is a 360 degrees, and a bar plot is like, horizontally it's viewed. This is a box plot. A box plot is for outlier visualization. Anything that comes above the whisks and below this whisk will be an outlier to my data. There is nothing on this graph because it's pretty much a very small data set with only 29 observations, wherein, it is a very small sample which cannot give me an accuracy of my data projection. So I will invalidate it, but for practical purposes, yes, this is how we use data. But in realistic examples, if I was working on a 29 observation data set, I would really not be doing much of justice to the kind of data that I have to hand. Okay. We've just seen. The first step that once we install R, the first step that we do is get our working directory and set our working directory in R. That's using the get working directory command and the set working directory command. How do you load some data into R? We've just seen how we load data using the read.csv command. Okay. And this is the file name of the data, retail data segmentation. And we set the header to be true, which means we want all the column headers. And we're just going to view the data that we have to hand here, the retail data. We're just seeing what are the column names. Now, there's something called, once we get our working directory, set our working directory, and we have a data set, we want to internalize a few of the metamodel functions in R of the data set that we have to hand. The first metamodel command, and it's a very, very important interview questions because they'll ask you what are the different metamodel commands and they would expect you to name a few of them. If I want to see how many rows and columns are there in my data set that are imported, I give the dim command, which is nothing but the dimensions of my data set. It shows the number of rows and columns in the data set imported. It shows that there are 300 rows and 18 columns in my data set. The next metamodel command is the names command. Name command gives you all the column headers. So it's about 18 column headers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Because it showed me it had 18 column headers. Okay. The third command, strings command, will give you the depth of observations and breadth of variables. So what does the string command do? That's what you will be asked, and you should say that it gives you the depth of observations and breadth of variables. When you say depth of observations and breadth, I just got, when I give the name command, I just got the column headers. Here I'm getting, if my card ID is an integer, a factor, a character, what is it? And if it is a factor, with how many levels is it? If it is gender, it is a factor with only 2 levels, male or female. If it is a city, it is a factor with 4 levels only. I've got only 4 cities in my data set, Bangalore, Delhi, and another 2, maybe Hyderabad and something else, Karnataka. So likewise, if it's a premium customer, it's factor with 2, it's a yes or a no. So it'll give you the depth of observations and breadth of variables. You want to extract a subset of your data based on conditions. We've just seen that, how we do using the $sign. The subsetting from the retail data set, I want this column average purchase value greater than 60,000. And that's what I get in my viewing here. If I want to give multiple options from the retail data set, I want average purchase values greater than, and I also want average items purchased less than 6. It will give us the output here. So I've used logical operators like and or that we've seen in the previous operators. How to sort data using the sort command, ascending and descending. Okay, and the true or false is how many of my values are greater than 10,000 in the data set. If I want to find the middle value of my data, I give the median command, and it will give me what's the middle value for this from this retail data, the average purchase values, median value. Some of the univariant outputs from the data I've just seen. For each of the 18 columns, it's given me what is the mean, median, and the mode, and the maximum, and the highest, and the lowest. We'll study this in statistics. We haven't covered them. The summary command will show me the distribution of all behavioral variables. Okay. It will show me the numerical predictors as well as the dimensional predictors. Numerical are the mean, median, mode, and we will study them in statistics. And the dimensional predictors are various dimensional values like Bangalore city, Chennai, Delhi, and how many of the people represent each of that city. Okay. Okay. So that is the end of the presentation today. I want to do the R coding in the next session for what we've seen today. So we'll end the session here, and any doubts, I'm happy to take on any doubts. Hello? Hello? Hello?
Prema, were you talking to me?
Yes, yes, Karthik. I'm done.
Sorry, I was on
I've done the
another
session.
call. I didn't know who you were talking.
Oh, no problem, no problem.
Give me 1 second, Prema.
Okay, sure, sure.
Sorry, yeah, I dropped off that call. Yes, Prema, go ahead, please.
Yeah, any doubts,
I don't have doubts. Maybe questions, no, until I actually sit down and start programming. See, the basics of R is good to be knowing, like we discussed. Maybe from the audience, or maybe we can go further a little bit more into the coding. I'm good.
Yeah, today I don't want to do anything more because I've covered the basic. I want to do practice tomorrow.
Okay.
I want to show them in practical tomorrow. So then they can actually have more doubts if there's actually doubts, because, just the theory bit may not sound, it may kind of.
All right.
So tomorrow when we do the session, we'll do the practice of what we see.
All right. Thank you, Prema.
Yeah. Okay.
Sounds good.
Sure, Karthik.
Thank you. Thank you all. Bye now.
Okay, thanks.
Thank you.
Bye.